This is the question given in 2017 board exam in ICSE class 10. The question is, a gas cylinder can hold 1 kg of hydrogen gas at room temperature. So you have a cylinder which can hold 1 kg of hydrogen gas. 1 kg of hydrogen gas at room temperature. Then find the number of moles of hydrogen gas present in that 1 kg. So very simple question. You have to find the number of moles. What is the formula we have for number of moles? Number of moles of a substance is equal to mass of the substance. What is the mass here? What is the substance? Hydrogen gas. So mass of hydrogen gas divided by molar mass of the substance. Here the substance is hydrogen gas. Molar mass is nothing but molecular weight. So the mass of hydrogen which is given is 1 kg. We do numericals in grams. So 1000 grams divided by molar mass of H2. Hydrogen's atomic weight is 1. So H2 means 2 hydrogens. H plus H. That means 1 plus 1. That equals to 2 grams. So molar mass of hydrogen gas is 2 grams. So 1000 by 2 is 500 moles. So this is the number of moles of hydrogen gas present in that cylinder. So this is the first bit. Then, so you have 500 moles of hydrogen gas. Now in the second bit, you are supposed to find what is the mass of carbon dioxide that can that cylinder hold at the same temperature and pressure. Means under the similar conditions in that same cylinder, if you take carbon dioxide, then what will be the mass of that carbon dioxide? Instead of, if you replace hydrogen gas by carbon dioxide under the same conditions, means temperature, pressure should remain same and the same cylinder. In the same cylinder, what should be the carbon dioxide? Mass of carbon dioxide that can be taken in the same cylinder. Okay, so now here we use Avogadro's law. So as per Avogadro's law, when you take two gases of equal volumes, like volume of hydrogen is equal to volume of carbon dioxide. So how is it equal? Because you are taking the same cylinder, means the volume will remain same. Volume of hydrogen is equal to volume of carbon dioxide. So here the volume of hydrogen and volume of carbon dioxide is equal. So as per this Avogadro's law, if you are taking any two gases under same conditions of equal volumes, then number of moles of both the gases will be equal. So that means the number of moles of hydrogen will be equal to the number of moles of carbon dioxide. So that means already we have found that in the cylinder you have 500 moles of hydrogen. So the number of moles of carbon dioxide also must be 500 moles. Okay. So you are taking 500 moles of carbon dioxide in that cylinder. So then you have to find what is the mass. What is the mass of carbon dioxide? Mass of carbon dioxide of 500 moles. That is nothing but number of moles into molar mass of carbon dioxide. Molar mass of carbon dioxide. So here 500 into, what is the molar mass of carbon dioxide? Atomic weights of carbon and oxygen will be given. Atomic weight is for carbon is 12 and for oxygen is 16. So in this I have 1 carbon and 2 oxygens. So 12 plus 16 plus 16, that is 44 grams. So that is for 1 mole. 1 mole 44 grams. I have 500 moles. So 500 into 44 grams. So that equals to 22,000 grams. So if you replace hydrogen gas, with carbon dioxide in the same cylinder, then you can take 22,000 grams of carbon dioxide in the same cylinder under the same conditions. So this is the second bit. Right. The same question you have third bit. Okay. Third bit also there. What is the third bit? Third bit is if the number of molecules, if the number of molecules of hydrogen gas is equal to X in the cylinder, then calculate the number of molecules of carbon dioxide present in the cylinder under the same condition. If number of molecules of hydrogen is X, then he is asking us to find number of molecules of carbon dioxide under the same conditions. So again, Avogadro's law. As per Avogadro's law, if you are taking two gases of equal volumes under same conditions, the number of molecules also will be same. That is nothing but number of moles. When number of moles of two gases is same, the number of molecules of those two gases also will be same. So this is also a very easy question. Next, state the law that help. Okay, so in this, which law we are using? We are using Avogadro's law. We are using Avogadro's law for this question. Okay, so this is the question given in 2017 mole concept question. Next we do questions from 2018. Next question is from 2018. In 2018, this is the question given related to mole concept. 2018 question. This is the question. Aluminium carbide reacts with water. Aluminium Al4C3. Aluminium carbide reacts with water to form aluminium hydroxide and methane gas. And this is the equation: Al4C3 plus reacting with water, so it gives 4 times AlOH thrice plus 3CH4. Here it is 12. And relative molecular weight is given, that is molar mass. molar mass of Al4C3, that is aluminum carbide, is given as 144 grams, and for aluminum hydroxide it is given as 78 grams. Then he is asking us to find mass of aluminum hydroxide. Okay, he is asking to find the mass of aluminum hydroxide produced if 12 grams of aluminum carbide is taken in this reaction. This is the first bit. After doing this, we'll do second bit also. Okay, so in this you are taking aluminum carbide reacting with water. So this is the equation. So in this equation, aluminum carbide is reacting with water and forming aluminum hydroxide and methane. And is asking us to find what is the mass of aluminum hydroxide if you take 12 grams of aluminum carbide. So the relation is between aluminum carbide and aluminum hydroxide. So these two terms you are going to take here. So relation is between aluminum carbide and 4 moles of aluminum hydroxide. And this is mass-mass relation. Mass-mass relation. So here you will take molar mass. What is the molar mass of aluminum carbide? Molar mass of aluminum carbide is already given. So this is 144. So it is just 1. So 1 into 144. Otherwise simply you can write 144 grams. So when you take 144 grams of aluminum carbide, it will give you 4 into molar mass of aluminum hydroxide, 78. 4 into 78 grams of aluminum hydroxide. So this is the relation. If you take 144 grams of aluminum carbide in this reaction, then the product will be 4 into 78 grams of aluminum hydroxide. Right? So for this 144 gram, this much aluminum hydroxide you will get. But in the question, I am taking only 12 grams of aluminum carbide. If I take only 12 grams, then what will be the mass of aluminum hydroxide produced? Okay, so from this, we cross multiply this. X into 144 is equal to 12 into 4 into 78. Now from here, X we can write, so 12 into 4 into 78 divided by 144. Now this 12 in this we can cancel, that is 12 times, and this 4 again we can cancel 3 times, so that will be 78 by 3. 78 by 3. So when you divide 78 by 3, you will get 26. So 26 grams. Okay. So you will get 26 grams of aluminum hydroxide. Okay, 26 grams of aluminum hydroxide is produced if you take 12 grams of aluminum carbide. Now, in the same question is asking what volume of methane is produced if the reaction is carried out at STP. Okay, second bit, you have to find what is the volume. Find the volume of methane. Find the volume of methane. In the same case, if you take 12 grams of aluminum carbide, find the volume of methane if 12 grams of aluminium carbide is taken in the reaction. Okay, so now it is the relation between volume of CH4 and mass of aluminium carbide. So again, this aluminium carbide we have to take, and you will take the methane. Aluminium carbide and methane. So that is the relation here. So again we take this aluminium carbide Al4C3 and 3CH4. This is 3CH4. Aluminium carbide Al4C3 and 3CH4. But here the relation is between volume of CH4. Here we have to take volume, and this is the mass. 12 grams means mass of Al4C3. So here this is the relation between mass and volume. So when it is between mass and volume, so where you have mass, you will take molar mass. What is the molar mass of aluminium carbide? 144. So this is 144 grams. And this is volume of a gas. You have to take molar volume. What is the molar volume for any gas? 22.4 liters. And you have 3. So 3 into that quotient, with the quotient you have to multiply the molar volume or molar volume or molar mass, compulsory. So if you take 144 grams of aluminium carbide, so this much methane you will get. Now if you take 12 grams, if you are taking 12 grams of aluminium carbide, then how much methane is produced? So same thing we'll do here also. So this is the relation we got. Now cross multiply. X into 144 is equal to 12 into 3 into 22.4. So from here you can write X is equal to 0.4 divided by 144. Okay, so 12 in this 12 times, and 3 in this 4 times, and 4 in this 5.6 times. So you will get 5.6 liters of methane gas produced in this reaction. Right, so this is the question given in 2018 board exam. Right, now we'll do the question given in 2019. Question from 2019. the question given. Calculate first one, the number of moles in 12 grams of oxygen, 12 grams of oxygen gas. And second bit, the weight of 10 power 22 atoms of carbon. So it's given atomic weight, oxygen's atomic weight is 16, carbon's atomic weight is 12, and Avogadro's number is given as 6 into 10 power 23. So this is the question given. Right. So from this, first you have to find the number of moles in 12 grams of oxygen gas. So for the first bit, we need to find number of moles. Number of moles is equal to, what is the formula? Mass of the substance. Here what is the substance? Oxygen. So mass of oxygen gas divided by molar mass of the substance. What is that substance? Oxygen gas. So this is the formula you are going to use to find the number of moles of oxygen. Number of moles of oxygen gas. Now what is the mass of oxygen given? 12 grams of oxygen is given, divided by molar mass of oxygen. In oxygen it is O2, means 2 oxygens are there, and atomic weight of oxygen is 16. So 16 plus 16, that is 32. So 32 grams is the molar mass. So 12 grams is the given mass and 32 is the molar mass. So 12 by 32. You can cancel 4 table. 3 by 8. So 3 by 8 will give you, if you divide 12 by 32. Okay, if you divide it, you will get 0.375. Okay, so this is the answer. 0.375 moles of oxygen is present in 12 grams of oxygen. And second bit, what is the weight of 10 power 22 atoms of carbon? So this is number of atoms. Again, from Avogadro's law, when you take 6 into 10 power 23 atoms of carbon, that will be equal to gram atomic weight of carbon. Okay, so if you take any substance, 6 into 10 power 23 atoms of any substance, that will be equal to gram atomic weight of that same substance. So here we are taking carbon. So 6 into 10 power 23 atoms of carbon will be equal to gram atomic weight of carbon. What is the gram atomic weight of carbon? 12. So 6 into 10 power 23 atoms of carbon will have weight of 12 grams. Then what will be the weight of 10 power 22 atoms? What is the weight of 10 power 22 atoms? So we cross multiply. So from here, x into 6 into 10 power 23, that equals to 10 power 22 into 12. So from this we can write x is equal to 10 power 22 into 12 divided by 6 into 10 power 23. So So 6 in this 2 times, and 10 power 22, 10 power 23, 10 times. So this is 2 by 10, which is equals to 0.2. You are finding the mass. So this will be 0.2 grams of carbon. If you take 10 power 22 atoms of carbon, so its weight will be equal to just 0.2 grams. Right, so this is the question given in 2019. Right, there is another question on mole concept in the same year 2019. So this is the reaction given, means mole concept, equation based mole concept question. So this is the equation given. 2 NaOH plus copper sulfate gives Na2SO4 plus copper hydroxide, and it is showing it is a precipitate. So that downward arrow shows it is a precipitate. So this is the reaction. He is asking what is the mass of copper hydroxide formed. Okay, he is asking us to find what is the mass of copper hydroxide precipitate. Okay, when 200 grams of sodium hydroxide is used. Okay, in case if you are using 200 grams of sodium hydroxide, so what will be the mass of copper hydroxide precipitate formed? And atomic weights are also given. Atomic weights: hydrogen 1, oxygen 16, sodium 23, sulfur 32, and copper is 64. So he is asking what is the mass of copper hydroxide precipitate we obtain when you take 200 grams of sodium hydroxide. This is the question. Right? So in this you have to take these two substances, 2NaOH and copper hydroxide, CuOH twice. Right? So 2NaOH and that is CuOH twice. So it is a relation between mass of copper hydroxide when 200 grams. So this is also mass only, mass of NaOH. So it is the relation between mass of sodium hydroxide and mass of copper hydroxide. And you will find the molar mass. Because this mass, you will write molar mass here. So 2 into molar mass of sodium hydroxide. Sodium hydroxide, sodium plus oxygen plus hydrogen. Sodium is 23, atomic weights are there. Plus 16 plus 1. So you will get 40 grams. So this is 2 into 40 grams. And this is copper hydroxide. Copper hydroxides at a molecular weight. There you have 1 copper. OH twice means 2 oxygens and H also 2 times. So if you take 64 plus 16 plus 16 plus 1 plus 1. I am substituting atomic weights there. 64 plus 16, 80, and this is 18. So this is 88. 88 grams. That means if you take 2 into 40, 80 grams of sodium hydroxide, it will give you 88 grams of copper hydroxide. For 80 grams of sodium hydroxide, you can prepare 88 grams of copper hydroxide. Now, if you take 200 grams of sodium hydroxide, then what is the mass of copper hydroxide? If you are taking this as 200 grams, then what is the mass of copper hydroxide? So cross multiply. So this into x, x into 2 into 40, that is equal to 200 into 88. 200 into 88. So from here x is equal to 200 into 88 divided by 2 into 40. Right? Now you can cancel 0, 0 you can cancel. So 2 in this 10 times and 4 in this 22 times. So 10 into 22, 220 grams. So if you take 200 grams of sodium hydroxide, with that you can prepare 220 grams of copper hydroxide. Okay, so these are few questions on mole concept given in the previous years. Okay, right. We'll continue in the next class.